I would like to invite you for the last presentation, and I'm really happy that our speakers are already with us. So after these two perspectives about materiality, data centers, and infrastructure, we will have a kind of new alternative, maybe futuristic or maybe not, perspective on thinking about cloud and data. Monika, Seyfried, and Cyrus Clarke are with us, and I'm really happy that we will have this presentation that is based on the work Data Garden, that is one of the works that you can see upstairs within the exhibition. Monika is an educator, designer who works across disciplines. She's interested in science, ethics, and future. She collaborated in the past around different projects run by the European Commission. And Cyrus is futurist designer and artist, also native in blockchain. So he's going to tell us more tomorrow morning as well about that. And right now I invite you to listen the story of growing cloud in plants. Thank you.
Super. Dziękujemy bardzo. Zaczniemy i rozmowa będzie po angielsku. Cyrus is not fluent in Polish yet. So, yeah. Hello everyone, welcome to the story about Grow Your Own Cloud. But firstly, just a little bit about who we are. So the project Grow Your Own Cloud is a biotech organization that is looking into trying to build the new organic green data storage solutions, and it's working with DNA as a storage medium, and we'll go through it as we go in depth in our presentation. So we're really trying to challenge this idea of how can we transform data centers into from these entities that are carbon creators to carbon absorbers. And our work has been recognized by parties like United Nations, Ars Electronica, it's probably why we're here, World Economic Forum in Davos, and really pushed us to be working on that further. But just before we introduce ourselves, we just want to say that, our background is actually in design and arts. So we're fluent more in designing exhibitions, designing experiences, and mostly working with technology. The main technologies we are familiar with are mixed reality, machine learning, and recently, especially for Cyrus, blockchain. And we always try to kind of educate people around these technologies, challenge them, and create new experiences with them. But for today, we want to talk about our project, Grow Your Own Cloud. This is the founding team. I'm Monika Seyfried. I am originally from Warsaw, actually, which is great. And that's why it's so nice to be here. And yeah, Cyrus, you want to tell us a little bit about yourself?
Yes, of course. I'm Cyrus. I'm from London. I have a background in economics. And then I became an artist. And we came up with the idea to store data in plants through an artistic process, which is quite original, quite unique, actually, in the world. And the way we actually were able to manifest that, technically, was by working with Jeff, who's the third person in this trio that we have now formed. And he's a very, very well-renowned microbiologist, synthetic biologist, working with DNA data storage, and in particular has a lot of expertise in DNA data storage recovery using nanopore devices, which sounds very, very complex and is very, very complex.
Some of the places we had a chance to spread the word around how can we build new sustainable futures around data. And yeah, let's get down to business. Do you want to take over?
Sure. So, since the very beginning of the project, the premise of Grow Your Own Cloud has been that we store data in plants, which is probably a phrase that no one really uttered before. And originally, this is a purely artistic evocation, a thought. What could it be like? What would it feel like if we could do that? Where would it take us? And that's where the kind of story begins. So the reason that we were even thinking that question at all was because we were deeply thinking about data. And I think you've probably heard a lot of these things now because I think you've had like 5 hours of talks about how data is bad for the planet. But at a very high level, once again, just to make sure that we all got it, data storage, data production, data consumption is having a really negative effect when it comes to energy consumption and CO2 emissions right now. And to kind of coin that, to kind of like frame it in 2 words, we came up with this phrase, data warming, which is obviously a play on words of global warming. And that's just to highlight the fact that data centers are 4%, maybe more, of global CO2 emissions, and they are taking up a lot of energy resources, which is really important when it comes to renewable energy in particular. On the other side of things, which maybe is a little bit less known, is the fact that a lot of the data in the cloud is very, very rarely used. And that figure kind of varies between 60% to 90%, depending on which cloud provider you speak to. But that is a large proportion of the data. And at the same time that all of this is going on, we all know that we are constantly using more and more data as human beings. So there's this exponential rise in the data we are creating, we are producing, we are storing. And also you've got now machines creating more data. You've got algorithms creating more data. You've got blockchain requiring lots of data. You've got more and more intensive processes requiring more and more data. So basically, in summary, this is a very bad picture.
You go, on me?
Okay. So that seems like a bad picture, but we kind of thought, well, maybe there's some hope in this. Maybe there's something that we could look to that could offer some kind of respite from this problem. And that's where we came across the oldest storage device in the world, which is DNA. And DNA is, as many of you now know or maybe don't know, is a very, very efficient way of storing information. So DNA is obviously in your bodies, it's encoding information that creates you. So it's an information language system for that. But it also means we could store digital data using DNA as a storage medium. And it turns out it's a very, very efficient medium. It's something like 1 million times more dense than this computer, than a hard drive is. It's just that we're not very good at using DNA right now because we didn't create it. We created computational systems, we think we created maths and all those kinds of things. So we know how to master that very well. DNA wasn't created by us. It was either created by something or sparked out of nothing. And so we're trying to figure out how to work with it. And that's pretty challenging right now. But in theory, it's really, really revolutionary and can lead to a lot of amazing processes, like Monika will explain right now.
Okay, so this graph in a nutshell can show you how to transition from storing digital files, or actually what is the procedure of storing digital files in DNA. And to break it down, the digital file is nothing else than just the binary codes of zeros and ones. And you can sort of write it as if in a write it in the language of DNA, which is nucleoids, A, C, G, T, and A, C, G, and T. And then essentially what you can do is synthesize, so you almost can print those molecules and print new strains of DNA that then you can introduce or not to other organisms, which is what we are looking at. And to read it back, you just have to reverse the process. And so essentially, I know this is very technical, but what is interesting perhaps to understand is that this whole process is taking a digital file that is normally being stored in computers and is enabling to be stored in a liquid form. So suddenly which is very interesting thing for us at the beginning was a very interesting thing for us as artists, because suddenly you have a possibility of taking a picture and really playing with it and having it in a liquid form. This is not a rocket science. There's a lot of big companies doing that on large scale, especially in States. But our role was more to try and figure out how can we take that step further, and how can we use organisms as a starter, plants as storage devices. So we came out and started seeking a lot of different scientists that could help us understand how can we store data in plants. And there's a lot that we can tell you about. One of the most interesting things we found out is that the amount of data you can actually store in a plant depends on the plant's genome. The larger the genome is, the more data you can technically store. And when it comes to the genome sizes, it's very interesting because, bigger trees might have very short and small genome, and a tiny plant like Parisa japonica, which is having one of the largest genomes in the world, can actually store a lot of data. So it's a playful situation once you start creating these new technologies and interactions with nature. It's very unexpected. So I put here questions that we always get asked, and there's probably a couple of more, but we need to move on with the presentation. So, Cyrus, what happens if my plant dies and I have family tree JPEG in my plant?
It's a really dark time for you when this happens. Basically, everything dies, whether it's a living organism, whether it's a computer. These things all come to an end. I guess what's more important is what happens when that end comes about. So when a computer dies, it has a lot of parts in it which we could recycle, but most of those go to waste, and they can never be recovered, and we accumulate more and more waste. When a plant dies, it goes back into the earth, it's recycled into other organisms, it becomes food for other things, it just degrades into the soil. So it creates a really organic, natural way of recycling. In terms of the data itself, we can have lots and lots of backups, as you would today, with any other type of computational system. And what's really nice is that the backups can be in things like seeds, it could be in other organisms, it can be in liquids, it can be in many, many different biological forms. And of course, it could also be on a computer as well.
But it's also worth to say that even if the plant dies, you can still possibly read its DNA.
It's like a true crime drama. You can still trace the DNA for some time.
Yeah. And another question: can data reproduce and pollinate?
Yeah,
can we build open source new systems around that?
I mean, that's one of the most amazing properties of living systems, is that they can self-replicate, whereas non-living systems currently cannot self-replicate. We're actually working with a scientist right now who's trying to develop non-living life that can self-replicate, which is another whole thing. But at the moment, this is a big advantage that plants have.
Okay. So back a couple of years ago, we got to know about this technology, and we decided, okay, this could be a great side project. How can we challenge this ethically? Should we even do it? And so the first thing we've done in Copenhagen was, I'm laughing because some of the actors of that first pop-up experience, well, are here actually. But we've turned the flower shop in Copenhagen into a decentralized data center. So we were just playful. How can we create first experiences? How can we learn about, do people even like this subject? How do they feel about it? So we spoke into a very beautiful flower shop, and we decided to create this kind of experience where people could walk in, talk to the data growth expert, and bring their own files, and we would kind of take them to an on-site lab, which was in the back of the flower shop, and they could go through a procedure of storing their data files in a flower. Everything was completely fake, nothing was real, because we really tried really hard to kind of create this experience for people. We were really excited, and I think we overdone it, and we were not, we were kind of surprised that people so quickly were on board with the idea of storing data in plants. Through that experience, we've learned how do you communicate this type of science project? What is interesting to people, for people to actually store in the plant, right? So we were surprised as if they brought their own poems, pictures of the dogs that died, or their family pictures and so on. So we had actually quite a lot of interesting discussions, and that is still like a very big foundation for what we're doing right now, and I think it was quite of a good prototype. And so through that, we were mainly concentrated on how you create an experience of putting the data into the plant, and how do you co-create, was what we use in the design jargon, that whole experience. And then we decided, okay, like how can we get the data out, and how can we also leave the speculation and make it real. And this is where, oh my God, he doesn't like it. And so this is the data garden, which is what we have. We have an exhibition of that installation upstairs. And just before we played the video of this installation, just want to say a couple of words. This installation got a prize from Ars Electronica Starts Prize, which was a great push for it, and it started traveling around Europe, and it enabled us to kind of also test certain things, technical things, conversations in lots of different occasions. But really, if you go upstairs, you will see this like kind of weird tent with a lot of plants on it and some technical equipment. I like to think about it as like the end process of what we actually did around this exhibition, because we actually pushed on quite a lot of different aspects of the science. So we really focused on how creating the first plants that are having encoded data in them, and working with Jeff, and we were at the time in States, in Austin, and working on a scientific, not large, but quite still serious pipeline, and creating an experience around it. So there's a whole bunch of work that's been done and documented, and the kind of installation is like the very end. So let me play the video that explains the whole the whole piece.
Grow Your Own Cloud stores data nature's way, in the DNA of organisms. We seek to create a new type of cloud, one that is organic rather than silicon, and which emits oxygen rather than CO2. This involves working with DNA data science. This technology has the potential to store all of the world's data in just 1 kilogram of DNA. It works with organisms that create their own energy. It stores data in a format that never grows obsolete. The Data Garden is a new type of infrastructure for DNA data storage that promotes harmony between people, ecosystems, and technology. The installation features plants encoded with data. The encoding process involves converting digital data such as text, JPEG, and MP3s into a biological format using genetic modification to convert from binary to ACGT. In the Data Garden, data stored within the plant's DNA can be decoded using the latest genetic sequencing technologies. This process is triggered by introducing a liquid sample to a nanopore sequencer, which analyzes the genetic information to reveal hidden messages, sounds, and images to be experienced in the space. Working with nature to alleviate the threat of data warming, the Data Garden invites visitors to explore a world in which data storage is truly green through self-sufficient data ecosystems. This type of data center makes data an accessible public resource, open and shareable within communities. We began this work through
Okay, so just to say, on the left-hand side, yes, you have Jeff Nivala in Seattle encoding data in plants that he actually sent it to us through FedEx to Austin, Texas, where we were growing them for an exhibition for South by Southwest, which is like this big tech festival, which I think was a breaking point for us because we started being invited to these tech festivals, and we were like kind of, we're just this weird speculative wannabe startup. We used it to kind of just comment on the work, and suddenly people really picked it up and they started believing that we are a startup. So I guess at the time we started playing that game, which just to say, like, through, as I said, in this installation, we've managed to actually work with these biotech devices, started working on the pipeline on how you can encode data in real time, meaning how can you unreveal pictures and videos or small files from DNA in real time, which is, really a big step actually for us. So you can see it upstairs.
Yeah, and I think that's a good moment to say something about like our methodology, our practice, however you want to describe it. So we have this background in interaction design, which is very multidisciplinary. Then we're practicing as artists. Monika actually has a background in fine arts. I'm just doing art because I like to do it. And somehow we're connected to technology because we're really interested in that. And we also wanted to work with nature. And we just managed to create these things and force these things into happening by making the right contacts, having a vision, and then finding a way to make it happen. And it really shouldn't be happening somehow. It's something we just kind of forced into creation. And in particular, the part around the data garden, when we implemented it the first time, and managed to have the resources to do this for real, to put data into plants and then retrieve it from plants, which no one had ever done before in science, is quite revolutionary in a way, to think that two artists with no budget and just a kind of visionary dream could make that happen. And I think that's always worth sharing with people. And somehow from that point, everything has been rolling a bit more smoothly for us. It's not been that easy, but definitely been much easier to enable those kinds of things to happen. And we can say things like, yeah, we've been able to successfully store data in plants and retrieve it from plants. And that's a big breakthrough in what we've been trying to do, because at the beginning of the project, we didn't even intend to do that. We just meant to imagine what it might be to do that. So yeah, following the data garden, we were wondering what to do with the project. Again, we were like, well, probably we should go and get a job or something. But then we speculatively put in an application for the Ginkgo Bioworks creative residency, having very little hope of getting this residency, mostly because they never take two people, they always take one person, and typically they take people who are very well established. Yeah, so just so you know what Ginkgo Bioworks is. Ginkgo Bioworks is one of the world's largest biotechnology companies. It's the largest synthetic biology company. I'd say in probably 10 years' time, it will be like the Amazon of biology. That's what they're building right now. Nobody really knows about it outside of the industry because it doesn't really touch your life right now. But this is the next big technology wave. So you all know about machine learning, you all know about crypto. Synthetic biology is the next big thing, and was actually really important during the pandemic. So yeah, we were eventually offered the creative residency there, and that was a huge lift for us and our work and our practice, because it meant we could work very, very directly for, I think in the end, 6 months with some of the best scientists in the world, really thinking about the ethics of biology. Should we be doing these things that we're thinking about doing? Us as artists questioning what they're doing, which is always really interesting, and just having a really deep and meaningful exchange that was very inspirational for us, but also inspirational for them. And from that, we kind of started working more on actually making Grow Your Own Cloud into something which can have a real world impact. So I think we were initially very focused on delivering design and artistic experiences, but now we're very much more focused on, can we use that grounding and thinking, and especially an ethics-led approach to thinking about this kind of technology into actually developing this technology? Can we be the people to actually bring this into creation rather than an engineer or a scientist who typically would do this thing, who might think in a very different way and may not have the same kind of ethical mindset that we think at least we have. So to give you a bit of a background or a little bit of an inside secret about this technology, we talk a lot about how DNA is amazing and how we can store all the world's data in the back of a van. That's very often quoted about DNA, but in reality we can't do that at all. We can only store kilobytes of data, which is terrible because that stores 256 gigabytes of data, and I can also connect it to the cloud and have unlimited storage. So what's the point of storing data in DNA when I can only store kilobytes of data? It doesn't make any sense. The sense to us comes from the fact that the trajectory of growth of that technology is going to follow computing. So today it's kilobytes, tomorrow it's megabytes, then it's gigabytes, and then it goes beyond terabytes, it goes to petabytes, which no other technology can touch. We can't get to petabytes at that kind of scale with any other technology right now apart from DNA. And that's why we're interested in pursuing this as not only a green technology, but also a very efficient technology, and also something which is really magical is the fact that it can be intergenerational. It can last thousands of years if stored in the right way.
Yeah, so a year ago I moved to Paris and we decided to pursue and try to make it a startup, which was a very interesting journey. I think it was a very interesting year. So we were thinking that maybe it's worth sharing a little bit of that as well, to kind of transition from to talk about how do you transition from an artistic project into speaking to venture capitalists and what is the process of that, which is what we do on a daily basis right now. It's really funny. So yeah, I think one thing is just to mention the breaking point. We were invited to United Nations Climate Action Summit and think we got a prize from there and we were speaking about the project in there, and I think that was kind of where our minds started clicking, okay, maybe we can push it further. I think if that wouldn't happen, we would just leave it as this side thing that we can, from time to time teach or go and talk about at nice conferences like this one. So we decided, okay, this is our very basic strategy a year ago. This is, I suppose, what we're starting with. Correct me if I'm saying, yeah. So we're starting, how can we create first organic data products to aim for creating the first world organic data infrastructure, as we call it. And we started working with clients. We started thinking, okay, how can we start bringing it to the market? And this is where, for example, we worked with a big company, LVMH in Paris, creating an experience of storing some of their precious data into plants and creating this specialized kind of prototypey but very beautiful products. And then creating this experience of a flower shop that we kind of brought into their spaces. So we took over a space, we created and built this new flower shop. There was a lot of different plants. Each one of them would have very luxurious data encoded inside, such as JPEGs of old pictures from LVMH. LVMH is the company that produces all the luxury business in France. And so it was kind of funny because it was also challenging for us to understand how do you work with this type of company, and we know that if you want to develop this technology, sooner or later you have to. But I think what was very beautiful and interesting is that they've created a big conference around green data storage, or green solutions, right, for data. And they used a lot of the things that we were kind of teaching them throughout our collaboration in their internal communication, which is actually when you were kind of surprised, okay, we're starting to entering and educating a very, one of the biggest, I think one of the third biggest companies in the world. In a very tiny way, of course, it's not massive, but it's interesting to see that impact happening and knowing that they will start from now on, start thinking about how much data they're actually producing. Maybe they will not start storing, I don't know, movies from runways in plants, but at least they can start communicating the idea, and I think that was interesting to see. The other thing that happened this year is we didn't talk much about ethics because I wanted to leave it a little bit for this project. We received a fellowship from START, which is basically a European foundation, to develop a project with the city of Den Haag, and we call it Urban Data Forest. So essentially here we're testing this technology on a larger scale. So we're thinking, okay, as Cyrus said, there's a lot of data that we need on a daily basis, but 80% of the data, even in our phone, like how much of this 10,000 pictures you have in your phone, how much of it like you actually access on a daily basis? You rarely do, right? So we started thinking, how can we take the archival data and start storing it in the forest, in the city? How can we start also introducing new data forests in the city? So imagining really this faraway future from 2050 where people could imagine you're in Warsaw, you go to a park, and this is where you can store your data. It's a very challenging, speculative thought. At the same time, it's really something that we think can happen. So how do we start crafting that experience? Who has access? Who governs the data? Where is it in the city? How do you access it? Shall we even do it, you know? What if the data pollinates? I mean, this is more of on a speculative spectrum, but yeah, just really thinking through the city of Den Haag, which is a very great like kind of context. And right now we're actually in the process of going and finishing this whole big project. So I'm not going to go into details, but you know, working with architects, urban designers, thinking about the future of the cities in Europe, how they can become more sustainable and how can they start introducing biotechnology on a daily basis. We came up with the concept of 2 forests. One is more of a breathing museum. You can imagine turning a library, like Biblioteka Warszawska, or a museum, exhibition like Biennale, into a forest. And how do we think about creating this new experience where a museum becomes a dune? How do you engage with an art? How do you write up a piece of art into a plant and so on? And the other concept is about creating these communal spaces, almost like ogródki działkowe, where every citizen can kind of own a space and grow their own data. And through that we also build more, obviously, greenery in the city. And it's been an interesting work because, yeah, it comes down to working with urban designers, thinking about the Green Deal of European Union, their future thinking of how they want to introduce more green in the city is really hard. There's no such a thing like unused space in the city. So in order to claim more nature, you actually come to that ethical, interesting dilemma of like, but this nature has data, and if it has NFTs in it, it can be worth a lot of money. You should have more data. You should have more trees in the city. So a lot of these kind of like interesting discussions, and also selecting the right native species. Right now, we're calculating how much this forest could actually store right now and in the future. What is the economical impact of that, and so on. Excuse me. So it's been a great research. It looks a little sketchy here, I know, but we're going to be exhibiting in November in one of the museums in Europe, where everything kind of will come together and also disseminate the research, hopefully share with you later on.
So that brings us to another project that we're currently working on, which is maybe a bit more contemporary, I think, if that's the right word, a bit more like of the now. The urban data forest is obviously our dream. That's something we've always envisaged since the very beginning of the project, because we always thought that it could be a fun way, like a Trojan horse, to bring trees back into the city centre. If you put data inside the trees become much more valuable. Urban real estate's quite expensive, so maybe that's a way to get the data back into the city with nature as well, instead of all the data being really far away. But we need to start somewhere, because that's not going to happen right away. And Monika kind of alluded to the fact that one of the... Slow, it's okay. We have a lot of time. One of the most precious forms of data, if we want to call it that, right now, is NFTs. And I'll be talking about that tomorrow a little bit as part of my talk, my macro talk on blockchain. And I think it was last year we were thinking, well, there's probably something we could do with NFTs as Grow Your Own Cloud, probably some kind of critique, because that's what we should do, because we're artists. But then we thought, actually, no, we could just do something much more cool than critique the NFTs. We could just make our own version with plants. So that's what NFPs are. They're non-fungible plants. And with non-fungible plants, the idea is basically, you can ignore what's on the screen right now and just listen to me for a bit. But non-fungible plants are basically very similar to NFTs. So NFTs are tokens. You take a file, you create a cryptographic hash, you associate that with the file, it's a unique hash, and now you have this unique token. That's why it's non-fungible, it's unique, not like Bitcoin, which is fungible, because you can swap any Bitcoin for another Bitcoin. What we're doing with non-fungible plants is a little bit different. We're actually taking the file itself, let's say you give me a song, and we're putting that song inside of the plant, and that makes the plant non-fungible, because now the plant is unique. The plant was already unique, to be fair. Like, all organisms are unique, but it's okay. We take some artistic license in that. So that's what we're doing. We're making non-fungible plants, and we're launching that in the Non-Fungible Plant Garden, which is a website, a kind of garden-themed, not metaverse, but metaverse, where you can explore different artistic creations in plants, and then you can actually buy the real plants, and we will mint them or grow them for you. And we're actually working with some quite well-known artists who we can't reveal right now, but that will be revealed in the coming months about what we're doing, and you'll probably hear about it because it's very fun. And it's all around a strategy we're developing right now, which is around something we call Web3. So probably you heard about Web3, and Web3 is a kind of term to describe the next evolution of the internet, where we go from the web to Web 2, a more rich, interactive internet experience, to Web 3, where you add value into the mix. And we're thinking, well, that's okay, that sounds good, but what if we bring synthetic biology and nature into that mix as well and make Web 3? So that's what we're doing, and we're growing a community, we're growing a DAO around Grow Your Own Cloud to make that happen. I know it sounds like kind of fun and silly and you're giggling, but it's actually quite serious, and it's something we're doing with Ginkgo Bioworks, MIT, Polygon, like quite well-known companies who are really behind this vision. It's really a moment in time, I think, where this kind of idea is important. The whole point of it being fun and silly is to get you entertained, but actually behind it's a very serious message. And that's what we're trying to do. We're trying to use what we're doing with Grow Your Own Cloud, where we've always spoken in a very serious way to very serious artistic people and scientific people and design people, and now reach a bit more of a mass audience by being a bit more Web3, basically.
I think if you have time tomorrow to join Cyrus's talk around DAOs, I think it's super worth it, because just to say, like, I'm not a crypto native, which means that I'm not super well educated in that field. I don't hold a lot of assets in crypto either, but I see an amazing stuff happening through crypto. It's really incredible, I think. I think everyone should start really educating themselves on that, starting with me. But, the most interesting things that I start noticing is how people are, building their own scientific pipeline, scientific projects that are being sponsored by the communities And people are pushing on development and then support for different communities around the world, development of new technologies, support for artists, support for Ukraine, a huge movement in crypto for support for Ukraine. And it's all through building these decentralized autonomous organizations, DAOs. For us, of course, we can always, I know we tend to think that these are not two routes of how you can fundraise for such project, of course, but I think there is a lot of potential for taking off the ground projects through crypto spaces, which are actually real, and there's a lot of very successful stories. So that's why we're also thinking about launching a product, creating community, and also generating value through that, of course. So it's also like a business model that we're trying to prototype. Oh, I forgot we have this.
How did you forget?
I forgot. Do you want to talk about it? Yeah, okay. So we're excited we're going to finish our talk very soon, but just to say, we're excited to see the work spanning across different spaces, so from art to business and these big companies that we've managed to work with. Recently we got invited to co-create a new series of Netflix show, which is about the future of, and we are featured through Christina Agapakis, which is a great educator, I suppose, practitioner of biotechnology. She introduces the concept of growing on cloud in the episode of Future of Plants, which was released last Monday, and next week Cyrus is going to be in the episode where he's going to be kind of digging deeper into the DNA data storage. So we're really excited about that. So let's watch it.
Yes, we can totally change the world. We can do this. And it's going to be amazing.
With this app, we would know what the dog is trying to tell us.
Rent your own space pod. What if your data was stored in your houseplant?
As a concept, it's absolutely crazy. The thing is, it's possible. Do we want...
And so on. So, do you want to share any next steps, anything before we...
Please follow us on Instagram. We're also on Twitter. You can email us any of your plant-based questions at hello@growyourown.cloud, and you can visit our website at growyourown.cloud. And we'd love to hear any questions if there's time for that. I'm sure people have some.
Yeah, thank you so much, Monika and Cyrus. That was really, really interesting. I'm sure there's loads of questions, but I will ask you the first one, okay? Yeah. Because throughout your whole talk, I started wondering, since, as you said, we had previous talks, and we heard a lot about the security about data and how they are, protected and non-accessible and very prestigious and very important, etc. And everything you talk about is very community-based, like welcoming people coming to the parks of data storage, etc. So I would like to just understand how you see it, if it's safe, and if it's possible to look at it from this perspective, as well as the concept that people, when they store their data in whatever phones, laptops, etc., they usually think they're very important and they carry them with them. They have their laptops on them all the time and phones, and want to reach them quickly when they want the access. So I can't imagine that we walk around with these plants, everywhere, carrying them around, etc. So I just wonder how you translate it into the actual reality now.
Yeah, so I put this up again because I think this is really crucial to answer your question. So from very early in the project, we understood something about DNA, it's definitely not anything similar to the kind of data systems or infrastructure we have today. So we're not talking about real-time data, that's off the table, that's computational, that's digital, it's over here somewhere. That's the cloud, that's even phones, it could be hard drives because you can access them instantly. We're talking about archival over here, then the biological cloud, which is the green foresty thing there. And that is green, obviously. It can last thousands of years. It doesn't require any energy, or very, very little energy by comparison. And it's very, very dense, so you can store data in there for a long period of time without worrying about it. It's very durable. It's for basically all of that data that lives in the cloud that we don't really use very often. That's what we're really targeting with this project. And our ambition is that slowly we'll be able to take literally tiny pieces of that data and start putting it in this biological cloud. And one day, maybe we can put a lot of data in that cloud. We don't know if that's really ever going to happen, but that's our ambition. In terms of the security thing, I will refer you to Monika, who's doing some excellent research on that for the data forest.
Yeah, I think, again, it's like you can always design it in design, and you can think about open source data first. So you can reverse this technology on how can you build forests that are spreading the information that should be spread, right? I think libraries is a good example. But then we had quite a lot of conversations with scientists on how you can encrypt the data and what are the mechanisms of encryption, essentially, of how you create, similarly when you open your laptop and you have to put on your password, we can think of that, but in a biological sense, which makes no sense right now for us, but there's definitely a way to do it. So that you need to have a special key, and I have no idea, and I don't think Cyrus has any idea of how this could work, but of course you can design it or think about it in a way that you have a special key that opens a certain file for you.
Yeah, like imagine that your genome is the password. Only you can access it, which you could do via biological data storage, that kind of stuff.
Yeah. Like Face ID is what I think about, that is the closest interaction that I could think about right now in this kind of technology landscape that connects to it, right? Because every face is very different. This is what we would, I don't know, sorry, I'm just going, but yeah, it's not something we're thinking about a lot, because right now what we're struggling with is how can we put 3 sentences in a plant, and if we achieve that in the next 2 years, that would be really, I mean, we can do it already, I guess, but in a more sustainable way, that's going to be great.
Okay, so I have 3 quick questions. One is a joke, one is boring, and one is speculative. So first question, what is your favorite plant?
How do you call this thing that you do?
Dandelion. Dandelion.
Dandelion, which is mleczny Mohaviec, yes.
Okay. And the boring question. So the plant has to live, so it has to be coded anyway for a living, and I presume you take a space of what is called junk DNA, quite improperly, but is this the story of it? What part of the DNA do you take for the storage?
Yeah, ideally it would be the region. Sorry? Yeah, and ideally it would be this region of junk DNA. Right now that's actually quite hard to do because we don't have techniques available in plant science. We do, but in theory you could use something like CRISPR, which is a gene editing tool, to kind of target where in the genome you want to put the data. So for those of you who don't know, most organisms, including us, have a lot of junk DNA, which is DNA doesn't encode for your hair color or something like that. It's not doing anything that we know of. It might be structural. So in our minds, we thought, yeah, we could use that DNA. Right now, it's hard to target that DNA, but that's the long-term idea, ambition.
Okay, I see. And the last speculative question. I imagine there could be a dictator that could use some invasive species like, I don't know, invasive grasses or bushes to spread propaganda. And how do you feel about it?
I mean, it's happening online, right? Isn't it? So, I mean, it's this old question of, it's not the technology you have, is what you do with it. I don't think, of course, our point of view is that it's extremely bad, but it will happen if it's happening already. What is interesting is that a lot of military institutions are looking into plant storage from, for spreading secret messages and so on in space, which is interesting.
I have a question that is related to this CRISPR-Cas9 method of inserting of this gene editing, because I was thinking about like the possibility of damage of data, because we know that after changing some sequences, some unpredictable mutations occur. So it's not like the super safe method, especially if these are like more complicated and complex sequences. So I was wondering if it's really like, if it is a serious threat that the plant can start mutating even in this chunk DNA sequences. Because I understand that we have a certain redundancy in DNA, so it is possible to encode the same message on different levels, so on the level of the sequence of nucleotides and also on the level of amino acids, and to encode the same message on different levels, but still it is possible that the mutation can occur and damage the data. So have you thought about this possibility?
Can we answer it? Yeah, so this is what keeps me up at night. No, it's, yeah, I know, definitely. No, of course, yeah, we've thought about it quite a lot, and we've been speaking to plant, obviously we're not scientists, right? So what I say here is not going to be very accurate probably, but we've been speaking to plant geneticists, and they don't know that much about this stuff, actually. This is all very interesting. They don't really know what would happen if we insert a really long string of data. It's very hard to predict exactly what will happen because it is quite random, the mutations, which makes things rather complicated. Now, saying that there are techniques we can use, or there are approaches we can use, where we could target a part of the plant's genome which it would want to keep, right? So it might not be something active, but it might be something important in the structure of the DNA that it might want to keep. And we can insert chunks of data there. And by doing that, we reduce the risk of mutation affecting that data. If we randomly insert the data into the plant's genome, there's a random chance of mutation and a very, relatively high chance that it will change the data. If that was to happen, there are other things we can do, things like error correction, which can enable us to revert back to what was put in. That just requires some kind of work on the input, let's say. But yeah, this is very much part of our exploration right now. It's not something we have definitive answers to, but for the NFP project, we have to, and we are finding a method to do that, even if it's for a very small amount of data.
I'm sorry, I just wanted to ask about the plant, because the data, I mean, yeah, it's important, but is it possible for the plant to be affected, like creating GMOs, creating mutated plants in the future that, who knows where it goes, But
yes.
It's quite inspiring, but also I was just wondering where...
Disturbing, yes. Yeah, of course. From what we know, no, it would not affect the plant, from what we've known, but this is exactly why we're trying to find sufficient funds to answer these questions, because, I don't know, I think we're living in this world where this could quickly happen, so you want to try and be the ones that are at least we'll try to do it in an ethical way. So what we know is that it would not affect the plant, but we would love to test if it would affect the ecosystem. But yeah, these are unknowns.
It doesn't affect, I mean, right now it doesn't affect the plant. It has no impact on the plant's characteristics. It doesn't change the plant in any meaningful way. It doesn't have any impact on the ecosystem because the plant doesn't change in any meaningful way. Of course, though, as Monika's kind of saying, there's like in very, 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 very extremely, I cannot even describe how low risk that, let's say I take a song by Kanye West and I convert that into DNA, that sequence could for some reason be a pathogen out of nowhere. And it might be a pathogen that we don't have in our system, so we can't verify that it's a pathogen before it goes in. But it's so low, the risk of that happening, that I don't think we can stop science on that basis. I mean, we could as well, but probably we're not going to, right? That doesn't make any sense. That's the risk that we face right now. Saying that, I mean, it's a slippery slope. So we're doing data storage in plants. Next step, people will come to us and be like, oh, what if the plant was also pink? Now we are changing the plant in a meaningful way. So you've got a song in a pink plant. What if the plant emits a nice rose smell when it rains? Now you're making an impact on the ecosystem too. So yeah, there are things that might happen as a result of this project. It becomes a kind of slippery slope. And that's why we're doing this, because we want to be thinking of these questions before, like we want to be ahead of those questions rather than like making things and then being, oh shit, now it's gone, it's really bad, like Facebook. Oh crap, what can we do now? It's everywhere. Everyone's using it. There's nothing we can do. I'm also a billionaire, so I don't want to actually do anything about it. So we're trying to be like ahead of those questions and try to find a way to like preempt them as much as we possibly can.
I have a question, but I also have a small answer to your question, because I was wondering that I guess that's why you use these non-coding regions to store data to avoid that you don't affect the coding regions that determine how the plant is. So I guess in general, I mean, theoretically, it shouldn't affect the plant. It's like GMO tomato or a GMO crop, and we already have them, and it will be the same way, as I imagine. Yeah. So my question, I have two questions.
Is your background in biology?
Yes. So yeah, my first question is, was the plant your first idea to store data because of the like artistic touch? Because I was thinking of bacteria to store data. I think that was the idea that I remember from my studies, that bacteria is like very easy to replicate and potentially easier to maintain or like to just feed. And also why having an organism or a cell, like in context of bacteria, instead of having storage or archives of DNA that can be just dried. You don't even need the cooling system. You don't need to freeze it. You can like dry it or like lyophilize bacteria, and you would have the same storage system. So that's my first question. Yeah, maybe that's first.
Yeah, I think we tend to joke around that we started with plants just to get attention because it's just a novelty. I think people love plants. They are very emotionally connected with plants. And it's a very good storytelling to be starting thinking about problems such as how data is warming up the planet. In terms of utility though, yeah, of course, trying to think about organisms such as bacteria or, I don't know, storing it in soil or other, places could probably eventually be a better idea. And I don't think we ever think that that is a closed door. So we started with plants from the storytelling perspective, if to answer your question. We started purely from a simple question we ask ourselves, can we communicate with plants? It was just a very, funny conversation we had, and then we started digging deeper. But yeah, in possibly working with other organisms or other entities of natural world would be interesting. Still though, plants are really good for us, right? They're very successful. So in a way, it could be that if we master it, it could actually be one of the best organisms to be using in this technology. And why not DNA? Yeah, because plants are just, they can take in CO2, they grow. Right now through the research in Hague, we're doing quite a lot of studies on how they're regulating territories that are under climate change pressure, right? Like Netherlands is really struggling with the amount of water that might come, and they're just planting trees because trees are regulating water, and they want to avoid getting flooded through that, right? So there is a lot of things why trees, plants are going to become the main things as we start facing like real climate change issues as well.
And they're just nicer looking than bacteria.
Yes.
Plants.
Yeah.
And smelling better probably.
Can
I was also thinking of the...
yeah, please.
That is the idea of storing data. You mentioned like a plant containing a song or a different plant having a picture. Would you aim for having like one plant that would store like all your data from your computer, for instance? Or do you like consider having like pieces of data stored in different plants or different organisms? Or like a garden would store, like every plant would store something different, I imagine. Because you mentioned the limit of storing more data, that plants have the limitation of this storage.
Yeah, so it's just a constraint of technology now. That's why we're thinking one file, one plant. I mean, if we could store an entire computer, we'd probably be having a really great business right now, right? So we just can't do that. So eventually, I presume that would be what we would look to try and do. We'd look to try and archive lots and lots of data in a single plant. We can do that because plants have very large genomes, some of them. But it's just where the technology is right now. That's not really possible.
I also wanted to ask if you are looking for any interns
we actually
with a biological background, but
we actually wanted to ask you if you're looking for work. So
I'm looking for a change of my
fantastic. Let's stay in touch. Perfect. Maybe we can convince Cyrus to build some operations in Poland through that too. That would be amazing.
Yeah, we are like generally hiring. So.
Hey, which blockchain you choose for the DAO?
Which one do you think?
I don't want to guess.
Guess.
I hope you developed your own.
Develop our own blockchain?
Yeah.
No, we won't do that.
Ethereum?
No.
Solana?
No.
I don't know.
We're working with Polygon.
Okay, yeah, you've mentioned that they are interested in the product.
They're very green. That's the only reason. I mean, we wouldn't work with. I would like to work with Ethereum, but it's impossible right now, given the impact on the planet and given what we do with our project.
Okay, so just to fill people in.
No.
There are different ways of storing your information on blockchains. Some of them are they're all bad for the planet, but some of them are trying to be better than the others. So Joanna is really questioning us on, are you making sure you're choosing the one that is better than the others? Ethereum, which is where all the billionaires are having assets with probably, and is the most popular one or whatever, it's not that good, but there's a lot of work being done to trying to make a blockchain that is more green. And recently even Facebook partnered up with Polygon, right, to develop the technology. So it's all greenwashing, but we're trying our best. We're really trying our best.
There's a huge opportunity in a way you can like build your own blockchain, and it's based on open source foundation, and it's you can really make sure that it's really low emission solution. So, but I guess it's not that major enough to be able to host your project. So.
Yeah, it's too much of an undertaking, and there's a lot of projects which are doing a really good job of doing exactly what we would do if we were to build it ourselves. So that doesn't make that much sense. And I don't really agree with you saying like everything is greenwashing, because like the statistics around blockchain consumption, I mean, I'll talk about that tomorrow, but it's quite interesting when you think about the things which consume energy and things which don't consume energy, which are around us all the time, like escalators. They consume much more energy than any blockchain. I mean, that's a really silly thing to say at the same time, but it's true. Yeah.
Another question I have. You've missed my presentation, but...
Sorry, what? I didn't hear.
You've missed my presentation, but the idea was that I made the slides in an assumption of small file philosophy, and like the whole presentation I keep under, it was like 800 kilobytes. And so my question is, I think from my perspective, there's one point missing, that you are trying to develop a solution that solves the problem, but instead not changing the way how our relationship with data, in a way we could produce it at less, or take more responsibility in a way of the quality of data that we want to store in plants or whatever, because it's like it's looking for a solution rather than looking for like mentality switch that could like actually solve this problem. And you mentioned at the first slide that there's like 80% of the data that is like out, it's not used, and it's matter of like unstructured data, that there's like no actually idea of what we can do with it. And again, I think that's the proof that the problem is in us, and in a way, and in our relationship with data, rather than looking for something that could actually cover our unlimited behavior in a way, how we produce and how much we transmit of data.
Totally. I mean, I think in our project, people immediately understand that we're producing too much data. And our project is very much designed to be a hopeful, positive message versus a critique of humans, or, I mean, obviously we are not like super positive about everything we're doing as a species, but we're also not trying to be very heavy-handed and very, very critical. We're trying to be a little bit more rosy and hopeful, which is just our particular take on things. But completely agree with you. I mean, obviously we would imagine, and we do that, and we've done a lot of campaigns around like trying to educate people on using less data in whimsical ways and very serious ways. So we definitely are on board with that. But I think where we're at with the project now is that we kind of have to choose a message that we're going to be on. And the message that we're on right now is that there's exponential rise in data, and there's not much that we are going to do to stop that, like the two of us.
It's not growing from somewhere, it's growing from our behaviors.
And also outside of our behaviors, because it's exogenous as well. So there's also algorithms and machines that are going to be out of our control, that are going to be creating more data than we will be able to control. So definitely, yeah, on one side, there's something about change management and advocacy and systems and regulations and things like that. And that's part of the solution. And another part of the solution is actually finding ways that data isn't harmful or less harmful. And those things should obviously work together and be symbiotic and work together, because they're trying to do the same thing, right?
Yeah, I would say like this is going to sound very corporate, but in the things that we're launching now, we're thinking a lot, because we also work with you on the research on that, and we're thinking a lot about how can we also in the communication reduce the impact of data and not produce that heavy files and so on. So that is kind of coming, but at the same time, it's just honestly just we cannot do everything at the time, I think. And we also, unfortunately, which is I think worse, I mean, we have to also choose a certain language to get access to certain people in order to then have impact in the future, let's say. I know that sounds very whimsical, but that's how I feel about it sometimes. And that's why we choose certain methods and testing it than the others, of having this kind of pitchy deck communication, because that gets us to, I don't know, being understood by certain people, that if we would bring something else would be like, well, I don't, it's very challenging for me to understand what you're actually trying to do. But we're definitely trying to obviously, learn and try to change that behavior within people eventually, but we cannot just do everything. Especially now, we're very slow, very early, very small team, onboarding people, but even if we would like to. I don't know if that was the last question. I just wanted to say that I would really, really like to thank Biennale for having us and for incredible organization, communication, production, bringing us here and everything. It's just been a pleasure. We've managed to work with small amounts of institutions, but definitely this collaboration was exceptional and very well done. And what you brought to the exhibition as well in terms of pieces is a very, just beautiful selection. So thank you so much for inviting us and having us as well.